Hello, hello friends. Today we will discuss about the sixth chapter of your syllabus, that is matrix method, in which we will see two methods. First one is a flexibility method, next one is a stiffness method. So what does it mean and why it is required? So matrix method is one of the best method if we have suppose more number of redundants, say redundant number is more than 2, then it is very laborious, or say it is a very difficult task to find out this resultants with the help of only simply manual calculation. So therefore we will require a matrix solution for this. So we have found out this two method, that is flexibility and stiffness method. So in which we will discuss about only flexibility method in this video. So let us say what is flexibility method. So flexibility method, it is one of the best method of force method, which we have discussed in section number 1, in which we can see the SDI value of any structure of the structure is very important, and in that case you have to form a flexibility matrix depending on that particular say structure. Okay, so in which we have to use a compatibility equation, as compatibility equation is given as R matrix will be equals to inverse of flexibility matrix into bracket delta matrix minus delta L matrix. So what it means, R matrix is nothing but the redundant matrix, which will be called as a force matrix, because it's a force method, and we will discuss about only we will calculate SDI value of this structure. That's why this R value, or say R matrix, is of redundant matrix, and each and every redundant will be a force value. Okay, and that will be a column matrix. If suppose two redundant values are there, then we will have two values in a columnar fashion, that is column matrix will be there. Okay, then we have to find out, then next one is a F matrix, that is a flexibility matrix. It will be a square matrix. If suppose redundant values are 2, then it will be square matrix of 2 by 2, and if suppose redundant values is 3, then this particular flexibility matrix will be a square matrix of 3 by 3. Okay, depending on the redundant values, you have to find out this flexibility matrix, or you have to form flexibility matrix. Next you can see the delta value, delta matrix. Delta matrix, delta is itself suggests it is a displacement matrix, but what is the difference between delta and delta L? Delta is a given displacement matrix, which will be once again a column matrix. What is meant by given displacement matrix? If suppose in a particular say problem itself, if it is given as a some settlement, if it is given some displacement is given in the problem itself, then that particular displacement can be counted as a delta matrix over there. Okay, that's why it is called as a given displacement matrix. That means this value will be given in problem itself. If it is not given, then this particular matrix will be a null matrix or zero matrix. Okay, once again it will be a column matrix, and the last one is a delta L matrix. That is once again a delta means displacement matrix, but this delta L stands for loading. So this delta L matrix is a displacement matrix due to external loading. Okay, and this will be once again a column matrix. Okay, now we will discuss about this, how to find out this all this matrix, and finally how to find out the redundants. Okay, that's okay. First we will see what is the flexibility, what is meant by flexibility. Okay, so for this we can see here flexibility, it is nothing but the displacement produced due to application of unit force in the assumed direction of a redundant. Okay, it is nothing but the displacement only which will be produced due to application of unit force. Okay, let us suppose a given structure having a redundant value 2, let us say 1 only, redundant value is 1. Let us say we will consider a propped cantilever. In that, the right hand support, which will be the propped support, is there. That particular support reaction we will consider as the redundant force. right? So for this resonant force, if you apply unit force in the assumed direction of that particular redundant that particular redundant, that is that particular support reaction, then the displacement produced, that will be called as a flexibility. Or in case of flexibility matrix, all the coefficient will be denoted as Fij, where I and j stand means what? I will give you what is Fij. It is nothing but the displacement produced at node 1 due to application of unit force in the assumed direction of redundant at node j. Fij displacement produced at node I due to application of unit force in the assumed direction of redundant at node j. Okay, I guess all of you are clear. Fij, that means first value, stands for displacement produced at that node, and second value j is that value where we will apply unit force in the assumed direction of redundant. So there will be a node. We have to consider which node we will be applying unit force and which node we are interested to find out displacement. Okay, that is two major important values or factors over here. Okay, is it clear? I hope all of you is clear. Okay, if any doubts you can ask me. In next video we will see a particular example how to solve a indeterminate beam with the help of flexibility matrix method. Okay, thank you.